Hello, IBSL2. Tonight's topic is 6.2. We are going to learn how to take the antiderivative of trig functions. So we'll be doing integrals of trig functions today. And what's helpful when you start to do trig functions is to first think about how we learned them when we took the derivative. So we'll first look at the derivative of sine of x, and then cosine of x and tangent of x, and see how that helps us remember our antiderivatives. So first, let's look at the derivative of sine of x, and if we remember, our derivative of sine of x is cosine of x. A derivative of a constant would be 0. Therefore, the derivative of sine of x plus c would be equal to the cosine of x. And also, if we would think about the antiderivative then of cosine of x, the antiderivative of cosine of x would be, or the integral, would be equal to sine of x plus c. And I forgot my dx. Let's make sure that's written here. Alright, so the antiderivative of cosine of x dx would be sine of x plus c. If we look at the derivative of cosine of x plus c, remember the derivative of cosine is negative sine of x. Let's just put a line in the middle here. And the derivative of c, a constant, would be 0. So our derivative of cosine of x plus c would be equal to negative sine of x. Therefore, if we took the integral of sine of x dx, we would get a negative cosine of x plus c. And this is because when we take the derivative of cosine of x plus c, we get negative sine of x. So if we're going to be taking the integral of the positive sine of x, that would be equal to the negative cosine of x plus c. Okay, and then our derivative of tangent of x, remember, is 1 over cosine squared of x. Our derivative of a constant would be 0. So our derivative of tangent x plus c would be 1 over cosine squared of x. Or, as we have seen, it could also be written as secant squared of x. Therefore, if I was going to take the integral of 1 over cosine squared x dx, that would be equal to the tangent of x plus c. So today we have learned our 3 basic integrals for trig functions, and these 3 are listed on your formula sheet. So let's take a look at the formula sheet and see how in the formula packet integral, and this is in the calculus section, where your standard integrals are, and they are listed, 2 out of the 3 of them are listed here. And so your integral of sine is listed and here, so that's your first rule. And a second rule that we learned today is the integral of cosine of x dx would be sine of x plus c. And then the third one is not on your formula packet, so it is one that you'll have to know, and that is the integral of 1 over cosine squared of x is equal to tangent x plus c. So these 2, along with the other 3 that we've learned last unit, are on your formula packet. This one you will need to know. You'll find that you'll end up memorizing these or just have them down so but when we get to the IB exam, these two will be on there and this one will not. So you'll need to make sure you know that. Okay, let's practice a couple of these. So I just have a couple examples, and remember the directions can be written several different ways. And here's the words written in words: integrate with respect to x. So example number 1. Let's go ahead and take the integral of 2 sine of x minus cosine of x with respect to x. So remember, so 2 sine of x, remember our integral of sine would be negative cosine of x. So the first part will be negative 2 cosine of x, and then our integral of cosine of x dx is positive sine of x. So the integral of negative cosine of x would be negative sine of x, and then we do not know if there's a constant, so it'll be plus c. So there's our final answer for problem number 1. Okay, so problem number 2, same directions, we integrate with respect to x, and our problem this time is 3 over cosine squared of x minus 2 over x plus the square root of x. So first I'm going to write it with my integral. And a few things stand out at me. I'm going to change this to x to the 1/2 to make it easier to take the antiderivative. And the other things that stand out at me is looking at this 2 over x. At this point, it should be clear to you that this is going to be our ln anytime you have c x in the denominator by itself there. And then now this is a new one that's strange, is our 1 over cosine squared of x. Remember, will be the tangent of x. So in this case we have 3 over cosine squared of x. And so when we take the antiderivative, remember that's going to be the tangent. And all of this is going to be respect to x. So let's go ahead and put parentheses around, because that's what our instructions said here, respect to x. So our first part is our new one that we just learned today, and that would be 3 times the tangent of x plus c. We're going to be adding on to the whole thing. 3 times the tangent of x. Here is our ln, so minus 2 times the ln of x, and then our x to the 1/2, remember we would add 1 to the exponent and divide by the new exponent, so x to the 3/2 divided by 3/2, so divided by 3/2 would mean it'd be multiplied by 2/3, and plus c. So a little bit of review in this problem, and especially of our ln, and when it's a radical, how to take the antiderivative. Okay, so there's problem number 2. We're going to be doing several of these in class, but before we try more problems, a few more things to think about. And that is when it's not, we first want to think about with integrals of when the trig functions have a form of f of ax plus b. So it's not as simple all the time when we have cosine of x. What happens when we take the derivative of cosine 2x plus pi over 6? Remember, when we take the derivative of cosine of 2x plus pi over 6, it would be equal to the negative sine of 2x plus pi over 6 times the derivative of the inside. So the derivative of 2x would be 2, and the derivative of pi over 6 is 0. So times 2. So that would be equal to negative 2 sine of 2x plus pi over 6. Therefore, if you look at it in reverse, if you're going to take the integral of sine of 2x plus pi over 6, that would be equal to the negative cosine of 2x plus pi over 6 times the 1 over the derivative of 2x plus pi over 6. So in this case, our derivative is just 2, so it would be 1 over 2. And remember, the negative sign comes in because the derivative of cosine is negative sine, so the antiderivative sign would be negative cosine. When we take the derivative of sine of 2x, remember that's equal to cosine of 2x, and the derivative of a constant would be 0. And when we take the derivative of sine of 2x, it's cosine of 2x, and then we have to multiply times the derivative of 2x, which the derivative of 2x would be 2. Then our derivative of our constant would be 0. So our derivative of sine of 2x plus c would be equal to 2 times the cosine of 2x. Therefore, if we're going to take the antiderivative of cosine of 2x, it's going to be equal to the sine of 2x times 1/2, because we'll have to divide by the derivative of our inside here, plus a constant, because we don't know if there was a constant in the original function. Our last integral of trig functions, again, remember, is tangent, and then when it's anything more difficult than just x, we have to remember of how we took the derivative when we take the antiderivative. So our derivative of tangent of 3x, remember, would be 1 over cosine squared of 3x. And then when we took the derivative, we multiplied by the derivative of this function here. So the derivative of 3x would be 3. And our derivative of our constant, again, is 0. So our derivative of our tangent 3x plus c would be equal to 3 over the cosine squared of 3x. So therefore, when we take the antiderivative, remember, this is all our fundamental theorem of calculus. We'll be doing this in reverse. So when we take the integral of 1 over cosine squared of 3x, we will get the tangent of 3x times 1/3 plus a c. If we putting this all together, if we look at the function with its integral, our function of sine of ax plus b, that's going to be our integral of sine of ax plus b would be negative 1 over a times cosine of ax plus b plus c. When we take the antiderivative of cosine of ax plus b, we will have 1 over a times sine of ax plus b plus our constant. And our last one, our rule 6 for tonight, is 1 over cosine squared of ax plus b. That's going to be equal to, I should scream at us, the tangent. So 1 over a times tangent of ax plus b plus c. Have a great night. We'll be practicing